The oregonator is the simplest realistic model of the chemical dynamics of oscillatory reactions. Through a complex reaction mechanism, the system is oscillating between a brown iodine solution and a blue starch solution. Some of the compounds are starch solution, malonic acid, sulfate manganese monohydrate, hydrogen peroxide, sulfuric acid, and potassium iodate. The raw X and Y data was digitized to create a plot of the oscillating colors of iodine and starch as a function of time. The X data was digitized by entering a 0 into a matrix for when no iodine was seen present, or a 1 if iodine was seen for every second. The Y data was digitized by inputting a 0 if no starch was seen present, to a 3 when the most concentrated starch color was seen. This oscillating reaction can be qualified from the digital data to examine the changing components in the reaction with time.
To quantify the rate constants for the 5 reactions examined under this mechanism, initial conditions were determined for the fit parameters. We have 7 variables at our disposal and observed how a change in each affected the fit to the experimental data. There is a higher oscillation reaction when the initial concentration of A, K2, and K3 are decreased, and when the initial concentration of B, K1, K4, and K5 are increased. There is a higher overall rate of consumption of the reaction when the initial concentration of B, K2, K4, and K5 are decreased, and when the initial concentration of A, K2, and K3 are increased. The peak iodine and starch concentrations are higher when the K1 and K4 are decreased, and lower when the initial concentration of A and K2 are decreased. Decrease in K3 shows a sharp decrease in both iodine and starch followed by a steady increase. Changing the initial concentration of B and K5 does not affect the peak concentration of iodine or starch.
The final values of the fit parameters that mirror the experimental data the closest were an initial A concentration of 900, initial B concentration of 700, K1 of 0.01, K2 of 500, K3 of 0.011, K4 of 0.98, and K5 of 0.001. The fit to the iodine concentration mirrors the experimental data well, and the starch concentration fairly well. There's a gap between the first and second oscillation in the experimental data that the fit parameters will not account for. The total reaction is ideally isothermic, but in reality is exothermic, which affects the K values and is not considered by the fit parameters. Further variance can be expected because the color changes recorded were subject to interpretation rather than using more accurate spectroscopic measurements.
And now, for your viewing pleasure, an unforgettable holiday special.
Hey, I think you misspelled unforgettable.